throughout this video, I'm going to probably say pause, and when I say pause on this video, I want to substitute, or if you're at home, to pause this video and answer the questions or complete the tasks that I assign before I say pause. So I need everybody to make sure they have 2 highlighters on their desk, and I need you to open up your table of contents. So I pause the video, make sure everybody gets their highlighters, gets open to the table of contents. In your table of contents, you need to end statistics, and the next section is called functions. Functions is up here on the board. It's also on the agenda. Okay? Functions. You need to end statistics, and you need to begin. The next line is called functions. Your homework last night, which was this piece of paper, is the first page in your functions section. So this is the very first page of functions notes. So make sure you get this homework assignment in your notes. Okay? So when you're good, if you want to pause this video to make sure everybody's caught up, you can. But when you're good, I need you to highlight your title. And I need you to highlight where it says, what is a relation? I strongly encourage you to have 2 highlighters, 2 different colors on your desk. It's going to make life a little bit easier today. Okay? So a relation. It is a list. Oops, I should write red. Hold on. A list of ordered pairs. When you go to the grocery store and you have a lot of items that you have to buy, chances are you make a list, right? You make a list that you need eggs, milks, and cookies, okay? With ordered pairs, if I want to make a list of those ordered pairs, it's called a relation. Your list of ordered pairs usually makes some form of picture. So on your homework last night, the very last example, this is a whole bunch of lists of ordered pairs. These are a whole bunch of relations. And this whole list made a beautiful Timberwolf, which I don't have up here. But this would be a relation. A relation can make pretty pictures like Timberwolves, or I can just make generic boring pictures which looks more algebraic. Okay? So a relation is a list of ordered pairs. This whole first beginning of the unit is nothing more than vocabulary. So everything you're learning today is vocabulary and you're applying it. You are not crunching numbers. You're not doing any kind of statistic stuff like we did last time. This is literally vocabulary you have to learn. Okay? So a relation is a list of ordered pairs. So it says, example, given the following table, create ordered pairs and plot them on the coordinate plane. So if I look at this first example, I have a table, my x values and my y values. X usually comes first, but I also labeled it just so you know. In an ordered pair, X always comes first and then Y. So if I take this first cell and turn it into an ordered pair, I have -3, -3. And then I'm going to put a comma because I'm making a list. I'm now going to look at this ordered pair. 0, 3. I'm now going to do the last one, which is 1, 5. In order to make a list, we use what's called squiggly braces, which look like this. So now I'm going to teach you how to draw them, because drawing a brace like this, look up at the board, that does not count. So here's how we draw. We're going to practice. You draw C, you draw a less than sign, you draw another C. C, less than sign, C. C, less than sign, C. When you get good at it, it looks the same thing. You can go a little bit quicker. To close it, you do a backward C, a greater than sign, and a backward C. A backward C, a greater than sign, a backward C. And then when you get good, you can go pretty quick. You have to attempt to draw these braces. A brace like this does not count. So if you need to pause the video to practice, you can, or we'll keep going. But in a relation, in order to make a successful mathematical list, it has to involve these squiggly braces. Okay? So now I'm going to pick up one of my highlighters, and I'm going to plot each of these ordered pairs. -3, -3. 0, 3, and 1, 5. Okay? And I'm not going to connect them, I'm just going to plot them. But if I did connect them, notice it makes a line. Notice this is a relation, it's a list of ordered pairs, but it's not nearly as pretty as the Timberwolf, or cute. Okay? So now, if I erase this, just so for purposes of me being able to see this example, this second example, this is what's called a mapping diagram. Notice I'm starting at -1 and it's pointing to 2. With an ordered pair, you always start with x, you go to y. So since you start here, these are your x values, and your arrowheads are your y values. So notice -1 goes to 2. So my first ordered pair is -1, 2. The next one, I start at 0, I go to 3. So 0, 3. You can put a comma there in between them. Now notice 1 splits off in two directions. 1 first goes to 2, so 1, 2. And then 1 goes to 1. I'm going to come down here and write it because I don't have enough room. And then 2 goes to -4. To make this a mathematical relation, I draw my squiggly braces. Okay? So now with my other highlighter, I'm going to plot all these points. -1, 2, 0, 3, 1, 2, 1, 1, 2, -4. And if I were to connect this picture, it looks a little different. It's still not as cute as a Timberwolf, but it's still a relation because it's a list of ordered pairs. Okay? Now notice something. Between these two examples, did you have an ordered pair in the list that was the same? Yes, it was 0, 3. So think about it this way. If your parents go to the grocery store, and your dad makes a list and your mom makes a list, and on both your parents' lists they write eggs. Are they going to buy eggs twice? No, they only buy it once. They don't worry about repeats as long as they get it the first time. This is crucial for where we're going. Okay? So now, let's talk about domain and range. Highlight where it says domain and highlight where it says range. Domain are all the values. Oh, sorry, let me write that. Let's start again. Let's say this. The values in the relation that represent x values. Domain are your x values in a relation. Range, they are the y values in a relation. So domain is x and range is y. So how do I remember this? In the ABCs, what comes first, x or y? X. And domain and range, what comes first in the ABCs, d or r? D. So since x comes before y, d comes before r, x is domain, range is y. Okay? So I'll give you a couple more seconds to write this down if you haven't. Alright, so if I look at this example, it says find the domain and range of the ordered pairs from the first example above. So I wrote that first example up here, okay? So I'm going to first find the domain. So I'm going to highlight domain in one color. So I'm going to highlight it in yellow. Domain represents all my x values in the relation, okay? So in this order, this relation, I'm going to highlight all of my x values. I'm highlighting to keep it very different in my head, okay? So domain, my x value is -3. In 0, 3, my x value is 0. And 1, 5, my x value is 1, okay? So I'm going to come down here and I'm going to say d equals. In order to write my domain, I have to first put them in order. -3, 0, 1. I then have to use my squiggly braces because that's the mathematical way for how I write domain and range. It's how I write my lists of data. Okay? And then the other last criteria for writing domain and range is you can't have any numbers repeat. Notice -3 is in there once, 0 is in there once, and 1 is in there once. So I'm going to come over to this sunburst, and I'm going to write criteria. 1, 2, 3. First criteria, order numbers. Numbers must be from smallest to biggest. Second criteria, don't repeat numbers. And the third thing, I have to use squiggly braces. If you don't match this criteria, you will lose points. I would take a highlighter and I would color your sunburst. It's super fun if you try to do this without picking up your highlighter. Good luck. Okay. So in order to write the domain and range, I have to order my numbers, which I did. I have to not repeat numbers, which I didn't. And I have to use squiggly braces, which I did. Awesome. So that's domain, so I'll talk about range. So if I go back up to this ordered pair, I'm going to highlight all my y values. So -3, 3, and 5. If you hate highlighting, great. Use an underline, circle, use a pen. Okay? But highlighting them makes them stand out so it's easier for your brain to see, because this is really easy stuff you don't want to mess up on. So my range is -3, 3, 5. Make sure they match the criteria. They're in order. No numbers repeated. And I use my squiggly braces. Make sure you're pausing this video if you need more time or whatever have you, but I'm just going to keep going. Okay. So now it says find the domain in the range of the second example. So I've got to come back up here and write the second example. -1, 2, 0, 3, 1, 2, 1, 1, and 2, -4. Okay. So I'm going to find my domain first. Domain are all my x values. So I'm going to highlight all my x values. Okay. So I'm now going to put all of those numbers in order. So D equals squiggly brace. So I have -1, 0, 1, 1, 2. If you were to write this like this, you're going to lose points. Here's why. These numbers, you already have 1 in there. You don't have to repeat it. When you go to the grocery store, if you're making a list for your mom and she says put cookies on the list, you don't write cookies 42 times. You write cookies once. You could try to write cookies 42 times and hope she'll buy 42 boxes of cookies, but chances are that's not going to happen. So you write 1 once because it's already in there, and then you write 2, and you're done. So now let's talk about range. Range, all my y values. So range equals squiggly brace. You have -4, 1, 2, 3. There's 2 repeats, but I only need to write it once. Hopefully this makes sense. Make sure you ask for clarification if you need it. But I now want you to try example 3 on your own. So go ahead and pause this video. Take a couple minutes, try to solve this. And then we'll get back together and we'll talk about it. So in this example, I hope you really highlighted your domain, all your x values and all your y values, because it really does help. So if I do my domain first, well, I should do yellow to keep it the same. Domain 4, -2, -1, 4, and -1. So my domain is -2, -1, 4. If you hate highlighting, you can also cross things out as you go. Range 3, 1, 3, -2, 1. -2, 1, 3. Oh gosh, that's terrible. Okay. So now let's look at the last example. When we have a table, life becomes really nice, because these are all your x values, these are all your y values, so this is your domain, this is your range. It makes life so much easier when it's a table. So D equals -9, 2, 3, 6. Range equals -6, -1, 4, 8. Make sure if you have any questions you're asking. If you don't have any questions, go ahead and flip your paper. What is a function? So I need you to take your highlighter and I need you to highlight the border of this box, please. I also need you to highlight where it says what is a function. A function is a relation where every x value belongs to only one y value. Every x value is only belonging to one y value. Each x value cannot go to multiple y values. So think about a husband and wife. Every husband has one wife. If your husband has more than one wife, something's wrong. But also, that means it's not a function because it's going to more than one wife, which is a y value. Okay? So every function is a relation where every x value belongs to only one y value. Remember, the word relation means ordered pairs. It's a bunch of ordered pairs where every x value belongs to only one y value. So if I have 1 going to 6, 1 can't go to 7. 1 can't go to -2. 1 can only go to 6. 1 can only go to one y value. Okay? So the biggest thing about how do I remember if something's a function or not? X values can never repeat. X values can never repeat. That means they're only ever going to one y value. So when I'm looking to see if something is a function or not, I have 3 different ways in which I can determine. As to pass the vertical line test, looking at data, or using the mapping diagram. So we're going to look at the vertical line test first. So I'm going to erase this. I want you to highlight where it says method 1 vertical line test for me, please. And what you're going to do, let me see if I can actually do this where you're going to see it. Let me draw this here real quick. You're going to take your pencil, which is this black line, and let me see if I can change the color of it here. Oh, yes, I can. Awesome. All right, fabulous. So I'm going to take this pencil, and I'm going to hold it vertically. Notice it's vertical. And I'm going to move this vertical line from left to right on my graph. And when I move this purple line left to right on my graph, this purple line may never touch my graph more than one spot at a time. So notice if I start at the beginning, it's touching, 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 touching. It only ever touches in one spot at a time. So this is yes, it is a function because it passes the vertical line test. Okay? That's what it means if something is a function. This purple pencil can only ever touch my line in more than one spot at a time. If it ever touches in more than one spot at a time, I did something wrong. It's not a function. Okay? Let's now skip and go over to this problem right here. So I'm going to take my pencil, and I'm going to move my pencil from left to right, and see if this purple line ever touches my pencil, this purple line ever touches my picture more than one spot at a time. Look right here. It touches here, and it touches here. So not a function. It also failed here. It touches here, and it touches here. It also fails here, because you make vertical lines and those all touch my picture more than one spot at a time. Okay? In order for something to not be a function, it may only fail once. If it fails one spot, if you can make it fail in one location, it's not a function. Okay? So try the backwards check mark. Take my pencil, move it from left to right. Does it ever touch more than once? Nope. So yes, it is a function. So I want you to pause this video and try the next 3 examples. All right, let's go over these problems. Let's do the z. Is the z a function? Oh no, I erased my purple line here. Notice if I move this right here, it touches here, here, and here. So no, not a function. Whenever I have to tell you why, if I say is it a function, yes or no, and you need to give me an explanation, this is your explanation for a graph. You draw a vertical line and you plot your points where it intersects more than one spot at a time. Okay? How about this middle example? Yes, it is a function. And how about this backwards u? Yes, it is a function as well. Okay? So now let's go over to the second page of notes where we're looking at data. Method 2, given data. It says, are the following sets of data of a function? How do you know? How do I know if something is a function? X values can not repeat. In order for something to not be a function, or to be a function, your x values can never repeat. I don't care about my y values, I only care about my x values. So if I look in this list, I'm going to highlight all of my x values. Okay. 4, 6, 4, 5, and 5. Do any of my numbers repeat? Yes. 4 repeats and 5 repeats. So is this a function? No. Now you're going to tell me why. Because, and here's how you're going to tell me. Instead of saying 4 and 5 repeat, you're going to say 4 goes to 6 and 4 goes to 3. You have to look at your y values because in a minute I'm going to try to trick you. So notice 4 repeats, it goes to 6 and it goes to 3. Or 5 goes to 19 and 7. Your x value can only ever go to one y value. You don't have to write both of these. You would really only have to write one of them. Okay? Let's look at the next one. In order for something to be a function, do I look at my x values, do I look at my y values, or do I look at both? I look at my x values. So I'm going to highlight all my x values. -3, -2, 0, 4, and 0. Is this a function? No, because my x values repeat. Not 4, excuse me. 0 goes to 7 and 5. Try the next one. Is this one a function? No, 1 goes to everything. No, because 1 goes to everything. Try the next one on your own. And so pause this video, try the next one. Let's see if you can fall for my trick, or not fall, should I say. If I highlight all my x values, 2, 1, -3, 0, 2. So right now you're about to say no because 2 repeats, but look at 2. 2 goes to 5 here, and 2 goes to 5 there. So is really 2 repeating, or is it copying? It's copying, just like a grocery list. If you put cookies on there twice, how many times are you going to actually buy cookies? Once. So whenever you have a copy, you can just cross out that duplicate. It's a duplicate, it's gone. So now that that copy is erased, 2, 1, -3, 0, is it a function? Yes, because no x values repeat. When you say yes, you're going to have to state the domain and range. So let's state the domain and let's state the range. Whenever I say yes, you have to give me the domain and range. So let's refresh. Domain, they're all my x values. So I have -3, I have 0, I have 1, I have 2. My range are all my y values. Hey, that's easy. 5. Look at the next two examples. Notice they're both number 5. 5 is very happy in this problem worksheet today. And I want you to determine if these are functions or not. Pause this video, take a stab. If you say yes, you have to give me the domain and range. So if I look at this first example, 5, it is not a function because 1 goes to -3 and 3. And if I look at this next one, yes, because no x values repeat. So my domain is -4, 0, 1, 3. And my range is -5, -2, -1, and 6.